Good afternoon,
Hello,
madam.
Minda.
Okay, so this is week 11, so we should continue on the topic of state space technique. So before we begin, let's begin with recitation of doa. Volunteer, please.
Al-Fatiha. Bismillahirrahmanirrahim. Amin. Bismillahirrahmanirrahim. Allahumma aftah alaina hikmataka wansyur alaina min hudaini rahmatika ya arhamar rahimin. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli.
Thank you very much, Rushaidi. Okay, so let's continue. Let's refresh back what we have learned with Dr. Shakirin from UMP. Before that, do you have any question on frequency response technique design as your preparation for test 2 next week? Ada soalan? Tak ada? Semua okay? Good enough? Okay, so kalau ada soalan bila-bila boleh tanya ya. Anyone of this group yang weekend ni pergi convocation dekat kampus Cawangan atau di Shah Alam, ada yang pergi convo? Tak ada? Batch you tak terlibat?
Ada Minda, tapi orang Atika dengan Syamimi.
Oh, okay. Dua orang je. Yang lain tak ada. You all? Rusyadi, you tak ada, tak pergi convo? Hishamuddin ada?
Saya tak pergi.
Okay. Okay, tak apa. So let's continue back. Okay, for state space, it will be in question 3 for your final exam. So during the group discussion, I've shared with you the time arrangement for final assessment and for part 2 of final assessment, which combine of question 3 and question 4, you'll be given 1 hour for both questions, meaning that you need to spend only 30 minutes for question 3 and another 30 minutes for question 4. Since there's no design for this topic and the next topic, digital control, so it will be a simple question compared to root locus design in question 1 and frequency response design in question 2. And beside the final assessment for state space and digital control, there'll be a simple assignment for both topics. Okay, so for this topic, the important part is you need to familiarize yourself with the state space equation as in equation 1 and 2. Okay, so if you are given a transfer function in S domain, meaning that the question might ask you to determine the state space equation, so you need to provide your answer as in following the format of equation 1 and 2, x dot equal to ax plus bu, and the second equation is on the output y equal to cx plus du. And the question might be extended to sketch the signal flow graph of the state space equation. So do you still remember the signal flow graph? Have you heard the signal flow graph before? Pernah dengar signal flow graph? Pernah dengar tak? Or is this the first time you heard about the signal flow graph?
I'm not so sure.
Not so sure. Okay. How about others? Signal flow graph. SFG.
First time Minda.
First time? Sure ke? I believe that you have learned before in your basic control subject. Signal flow graph. Okay. Sebab tu saya tanya dulu. Okay, but that's okay. Yang student yang belajar sem lepas pun sem ni lupa. You belajar masa diploma dah masuk degree pun lupa kan? Okay. So you'll be used again the signal flow graph. You need to sketch the signal flow graph based on this one. In previous basic control subject, you need to sketch the signal flow graph based on your transfer function in S domain. So instead of you draw a block diagram representing the transfer function in S domain, you also can representing it graphically using signal flow graph based on the transfer function in S domain. But in this topic, you'll be given the transfer function in S domain, you need to convert to state space equation, and based on the state space equation, based on equation number 1 and number 2, you need to sketch the signal flow graph. So the signal flow graph can represented both state space equation and also the transfer function in S domain. So after I introduce to you how to determine the state space equation based on the given transfer function in S domain, I'll refresh back what is signal flow graph is all about and how to sketch the signal flow graph based on the state space equation, not based on the transfer function in S domain. Okay, the next part is I want to add some. Okay, so don't worry, you do not need to sketch this block diagram representing the state space, but you need to sketch the signal flow graph to represent the state space. Okay, but if you notice, there's a integration block diagram in this block diagram that to represent the state space. This block diagram in a polynomial equation is actually equal to 1 over S. Ini tolong tambah dalam notes you. Okay, that integration function is actually equal to 1 over S. Okay, meaning that if you have x dot t on the left, and then you apply the integration process, which represented by 1 over S, the polynomial function, the output is xt. Okay, so you need to apply the integration process to determine xt from x dot t. Okay, from xt to get the x dot t, okay, this dot, you need to apply differentiation process. Okay, that's the difference between x dot to xt and x to x dot. So the dot symbol at the top of the parameter or variable, any variable x, y, meaning that the variable or the parameter has been differentiated. Okay, it's a derivative signal. Okay, I hope you clear about this one. Apa beza x dot dengan x? Can you follow me? Okay tak? Clear?
Clear, madam.
Okay, so you need to use this 1 over S polynomial function in your signal flow graph to represent the process between x dot and x. So antara x dot signal dengan x, dia punya gain tengah-tengah tu ialah 1 over S. Okay, done? This part, ni penting sebab nanti you kena sketch signal flow graph. So each part tu you kena label berapa gain dia, berapa coefficient dia, apa dia function dia. So one of them is 1 over S. Okay, one more thing. Okay, about the cofactor. Okay, Dr. Shakrin has explained very well on the cofactor, including the example. Okay, the one in the slide is a 3 by 3 dimension matrix. Okay, so it has for matrix A, it has 3 row and 3 columns. So the row darab column kan. Okay. So this is the cofactor. To determine the adjoint of matrix A, first you need to determine the cofactor matrix using this technique that has been explained by Dr. Shakirin. And then you need to transpose the cofactor. Okay, yang hari tu Dr. Shakirin tanya macam mana nak labelkan dia, you boleh juga labelkan macam ni, cofactor C. Cofactor A. Okay, COF, sebab you determine the cofactor of matrix A, so you boleh buat macam ni, cofactor A. Okay, and then you need to transpose the cofactor matrix to determine the adjoint. So there's two process. But for matrix dimension 2 by 2, for example, you have matrix B and the dimension is 2 by 2. Okay, let's say I represent the value inside the matrix based on A, B, C, and D. So to determine the cofactor B for matrix 2 by 2 is easier compared to matrix 3 by 3. Okay, the cofactor B okay. For matrix 2 by 2, you do not need to determine the cofactor. You can directly determine the adjoint of matrix B. Okay. So to determine the adjoint matrix B, which is a 2 by 2 dimension, you swap between D and A. Okay, then you change the polarity of B and C. Here. Any question? Okay, so to determine the adjoint for matrix dimension 2 by 2 is a direct one. You do not need to determine the cofactor. You can directly determine the adjoint by using this method. Ada soalan? Dah lunch ke belum?
Dah, madam.
Dah,
Okay. Jangan ngantuk tau. Kalau ada soalan, tanya je. Okay, that's it for adjoint matrix for 2 by 2. Apa lagi saya nak highlight? Okay, for this one, for multiplication. Okay, if you have real numbers in each matrix, you can use your calculator directly. Okay, so ingat lagi macam mana nak guna function matrix dalam calculator. Dah try explore you punya matrix function dalam calculator. Lama dah tak guna matrix kan? Dah try buat sendiri. A plus B sama tak jawapan dia dengan this one? Dah try tak? Have you tried using your calculator?
Ada, madam.
Okay.
Madam, kalau transpose tu boleh direct guna calculator?
Kalau dia semua real numbers boleh guna calculator. Calculator kan ada function transpose. You can explore lagi. Okay. So you the one that you can use calculator if your matrix function has all real numbers. But if you have polynomial numbers as polynomial function as +1, you tak boleh pakai calculator. Kan you boleh pakai calculator. Mana tahu calculator sekarang dah lagi advance. Ada lebih banyak function compared to previous calculator. Kalau you ada polynomial function, you boleh guna matrix dalam calculator kan, matrix function dalam calculator. Ada yang dah try? Tak ada? Okay. So kalau you boleh masukkan polynomial function s plus 1, you bagi tahu saya calculator mana yang boleh guna, model mana. Okay, mana tahu dah ada advanced calculator. Tapi setahu saya, calculator yang saya ada tak adalah, tak boleh masukkan polynomial function. Okay, usually because we are dealing with the transfer function in S domain and we want to change to state space equation, so you'll be given the S polynomial function in the matrix, so you cannot use calculator unless you have all the real numbers like this, then only you can use calculator. Okay, and then soalan dia tak ada direct, very basic addition, subtraction, multiplication, direct macam ni. Dia akan bagi in terms of polynomial number. So this one, the one that have been covered by Dr. Shakrin is a basic for matrix operation, so that you are ready to use it in the state space technique. Okay, so for this one, for multiplication, okay, okay, let's say this is matrix A multiply with matrix B. So dimension for matrix A are 1 multiply with row 1 multiply with column 1. Okay, this is the dimension for matrix A, and the dimension for matrix B is R2 multiply with C2. Okay, so the product of the multiplication based on these two matrix is R1 multiply with C2. Okay, yang dalam bulat merah tu. So the 2 kali 1. This one is correct. Okay. The other things that you need to check is, okay, ni. C1, you check C1 and R1. R2. Okay. If the numbers of C1 and R2 are equal, then only you can multiply both matrices. If not, if C1 and R2 is not equal, in this case, C1 sama dengan 2, R2 sama dengan 2, then you boleh multiply, dia akan ada value. But if the number of C1 and R2 is not equal, you cannot multiply. Kalau you try using the real numbers matrix A yang atas ni, okay, A multiply with B, dia tak sama C1 dengan R2, dia akan keluarkan sebagai dimension error menggunakan calculator. So dimension yang tengah-tengah ni, C1 and R2 kena sama baru you boleh multiply. Clear? This is the basic in matrix operation. Right. I'm not sure whether you realize it or not, but that's the fact. Okay. So the R1 and C2 ialah product of the multiplication. Dia dimension berapa? Clear? Okay.
Clear, madam.
Okay. For example, this one. Yang tengah-tengah ni, dimension dia sama. So, you boleh multiply. Yang tengah-tengah ni dimension dia sama, then you boleh multiply, dia akan produce 3 kali 3. Okay. Nanti you try this one. This one kalau you check matrix A 2 by 2, matrix B 2 by 3, matrix C 2 by 1, you check. Okay. Akan ada yang keluarkan dimension error. It's because of C1 dengan C1 dengan R2 tak sama nilai. Okay. For determinant, okay. Determinant is quite important because when you have a state space equation, you need to convert to transfer function in S domain. There'll be there'll be formula to determine the transfer function from the state space. You need to use the inverse matrix. So to determine the inverse matrix is equal to adjoint matrix divided by determinant of that matrix. So you need to use determinant method. So just choose among these three methods which one that you are comfortable enough and that can help you to calculate quickly and correctly during assessment. So pilih je yang mana-mana, 1, 2, 3 yang mana you rasa sangat comfortable, sangat membantu untuk buat dengan cepat dan kira dengan betul, you boleh pilih mana-mana. As long as your determinant answer is correct to be used to the other process. Okay. Kalau saya personally, saya memang suka method 2. Okay. So it's up to you. Okay. So this one has been discussed by Dr. Shakirin. Okay. So yang macam masa kelas tu Gifari ada cakap ada yang part yang salah kan, because of the bracket. So any operation yang melibatkan darab bahagi, ada polarity positif negatif, student punya mistake selalu dekat level ni. You punya understanding saya tahu dah, you punya understanding memang betul, tapi part ni bila you nak simplify into the final answer, kat sini ramai akan buat mistake. So please check betul-betul. You just need to practice you just need a lot of practices so that you can avoid the careless mistake during the assessment. So in order to make sure that the final answer is correct, you can get full marks. So be careful. Itu je saya boleh cakap because you have deal with this dah lama dah, bertahun-tahun kan, bracket, polarity, divide plus subtract semua. So be careful. Okay. And this one, okay, this one penting ni tadi you nak kira adjoint A, determinant A, so make sure you calculate it correctly because it will be used in the conversion from state space to transfer function. Ini sangat penting. Okay, so nanti kita akan go through by example. And then kalau dah habis lecture notes, baru kita try buat past year exam. Okay. Okay, so Dr. Shakirin hari tu dah cover this part kan. So yang Dr. Shakirin buat hari tu saya dah paste dekat tepi-tepi ni. So you boleh refer this one. You punya ni saya dah masukkan dekat dalam lecture notes group you. So dekat welcome ni, pergi dekat Dr. Shakirin cover yang ni. So saya sambung yang week 11 ni. Okay. Okay, so let's continue on this slide. Okay, this is a type of matrix, singular or non-singular. For singular matrix, if the determinant is equal to 0, then it is called singular matrix. While if the determinant is not equal to 0, then it is called non-singular matrix. Okay, that's the types of metric for singular and non-singular. Okay, listen carefully for this one. Okay, in this state space, we have a terms called eigenvalue. Okay, characteristic equation you dah pernah dengar. Stability, you dah selalu deal with the stability for the frequency response analysis, gain margin, phase margin on the root locus based on the pole and zero map on the left half plane stable, on the right half plane unstable, at the imaginary axis critically or marginally stable. Okay, this one is eigenvalue that has been used symbol lambda. Okay, nama dia eigenvalue. Okay, eigenvalue, okay, is actually roots of the characteristic equation of matrix A. Okay, same goes if we have the open loop transfer function, and from the open loop transfer function, we determine the closed loop transfer function, and from the denominator of the transfer function, if we equalize to zero, that is called characteristic equation. And we use the characteristic equation to determine to construct your root width table, if you still remember in topic root locus design. Okay, so in state space, we have eigenvalues as the roots of the characteristic equation. Okay, so this one previous lecture yang prepare slide ni dia dah provide YouTube link kalau you nak tahu lebih lagi pasal eigenvector. Okay, this is the characteristic equation for this state space technique. Okay, the absolute value or determinant of eigenvalue multiply with identity matrix, lambda multiply with I is the identity matrix, minus A, matrix A. Okay, A is the matrix A, equal to 0. Bila you sebut equation, dia kena ada on the left side, function on the, on the left side equal to the function or equation on the right side, then we can call it as equation. Kalau you tak ada part ni, that is not an equation based on the mathematical rules. Okay. Otherwise, if you are not prefer to use symbol lambda symbol, you can replace lambda with S. Macam you ada S dalam polynomial function in S domain transfer function, sama je. Lambda ialah S. Okay. So lambda or S is actually roots of the characteristic equation. In this case, lambda is the eigenvalues or roots of the matrix A. Kita refer kepada matrix A. Okay, you ada matrix A, B, C, and D. But the eigenvalues ialah is the roots of the matrix A. Bukan matrix B, bukan matrix C, bukan matrix A. Okay, so this equation is also equal to this equation if we replace lambda with S function. So S multiply with I, which is the identity matrix, minus A, the determinant of SI minus A must be equal to 0. So you kena determine matrix ni dulu. S multiply with I and then minuskan dengan given matrix A. Okay, soalan bagi matrix A and then you construct SI minus A. Then you determine what is determinant values, then equalize to 0. Then only you can determine what is the roots of the matrix A. Okay, ada soalan? Okay. Okay. For example, example 6A, saya dah sediakan solution. Saya sediakan solution untuk example 6A sahaja. Okay, in this case, okay, first you need to determine SI minus A. Okay, so this is your S function. This is your identity matrix. The identity matrix dimension must be equal to the dimension of the matrix given in the question. In this case, matrix A is 2 by 2. So your identity matrix dimension must be 2 by 2, meaning that you have value of 1 at the diagonal position. Clear? Minus A for this part. So this is a minus symbol. This is matrix A. Otherwise, if you want to save your time during the final assessment or assignment, you can skip directly. You can multiply directly S multiply with I. You will construct directly using into this format. This is SI minus A. So you tak perlu buat line 1. Okay. So SI minus A. This is A. Otherwise, if you want to skip line number 1 and line number 2, if you want to construct directly SI minus A, then you can construct this one. Okay, so I advise you to construct directly line number 3 to save your time during the assessment. Ni kalau you confident by not writing all the steps by steps, the detail calculation, and you confident that your calculation is correct, then you can skip line number 1 and line number 2, and you can directly write the solution for line number 3. Okay, so based on the matrix Si minus A, then you determine, you calculate the determinant of Si minus A, then equalize it to 0. Okay, so this is the characteristic equation. Then you can determine your roots of the matrix A, which this one is equal to this one. Clear? So eigenvalue, this one tadi ni you dah replace lambda with S. Kalau siapa tak nak guna lambda, that's okay. Just use Si minus A. So eigenvalues is the roots of the characteristic equation of matrix A. Ada soalan? Okay tak? Tak ada? Can I move to the next slide? Thank you, Calvin. Okay, so please pay attention since is this your first time learning about state space equation? Ada subjek lain yang belajar state space? Tak ada? First time. Okay, so listen carefully. Okay. Okay, so the first question might be, the question might give you the transfer function in S domain. Okay, so this is your transfer function. So you need to convert into state space equation based on equation number 1 and number 2, x dot equal to ax plus bu. U is your input. And the second equation is y equal to cx plus du. Okay, then the question might be extended to sketch the signal flow graph, SFG. Okay, so the SFG can represent your transfer function in S domain and also the state space equation. Okay, there are 3 steps to convert the transfer function in S domain into state space equation. Okay, so the first one, you need to cross multiply both sides of the transfer function. Ni, this one. Okay, that is the first step. Based on the given transfer function in the question. Okay, second step, you need to take inverse Laplace transform. Okay, based on this one, step number 1, you need to take inverse Laplace transform. You assume 0 initial condition. Okay, assume 0 initial condition. Initial condition contoh macam ni, X pada masa T sama dengan kosong, itulah initial condition. Contohnya, dia boleh jadi 0 initial condition maksudnya ni sama dengan kosong. Okay, contoh, dia sama dengan kosong. In the next semester course digital signal processing, you akan ambil masa semester 6. Okay, you akan jumpa lagi equation macam ni. Tapi dia tak semesti, it's not always, it's not all the time that the initial condition is equal to 0. It can be the initial condition equal to 1, -1, and etc. Okay, but for this course, we have to assume that 0 initial condition. So kalau ada function macam ni, kita assume dia kosong. Initial condition kosong. Initial condition pada masa T sama dengan kosong. Okay, ataupun boleh juga T sama dengan -1. Atau T sama dengan -2. Tu dia ialah initial condition. Dia boleh extend ke belakang lagi. Kalau current time ialah T sama dengan 1. Okay, that one is initial condition. Okay, step number 3. We need to select set of state variable. State variable yang mana? Ni yang dalam yellow box ni. Ni ialah state variable. You ada X1, you ada X2, you ada X3. And then you ada X1 dot, you ada X2 dot, you ada X3 dot. And then you ada C dot, C double dot, C triple dot. Okay. So dah ready ke? Nak buat step number 1, 2 and 3. Are you ready?
Yes.
Okay. Let's try example 7. Dia kena buat example 7. So in when we'll try past year question, you have to refer back to this example 7A or 7B. Okay, if you look at the given transfer function in example A and B, what is the difference between these two transfer functions? Apa beza dia? If you can observe. Apa beza dua ni?
Numerator.
Very good, Rushaidi. The difference is that numerator. Okay. Example A, the numerator contains constant only. Dia ada 24 sahaja as a function. For example B, it has polynomial function as in denominator. Itu beza dia. So once you dapat soalan, tengok transfer function, dia macam example 7A ke 7B. So you kena refer pada example ni. Okay, because these two different types of numerator function has its own method to determine the state space equation. Method dia agak sedikit berbeza. So make sure you jangan salah guna method. Okay, so hari ni kita try example 7A dulu. Okay, so in this case kita buat dulu transfer function ke state space. Dah habis state space baru kita boleh pergi kepada signal flow graph. So kita refer balik step tadi tu. Okay. So step number 1, cross multiply both sides of the transfer function. Okay, step number 1. Okay, so based on the transfer function given, okay, it has C over R. C is your output, R is your input. So depends what is the variable given in the question. Dia boleh pakai C, dia boleh pakai Y untuk output. Untuk input dia boleh pakai R, dia boleh pakai U. Itu yang popular lah. Tapi kalau dia pakai alphabet lain, you kena guna. Okay, in this case, first step you need to cross multiply. C darab dengan denominator, R darab dengan numerator. Okay, then you dapat ni yang step number 1 equation. That is step number 1, cross multiply both function, the transfer function. Clear? Boleh follow?
Okay.
Okay, next. Step number 2, take inverse Laplace transform of the transfer equation. Kita dah cross multiply, kita dapat satu equation on the left side equal to right side. Then we take the inverse Laplace transform. Okay, listen carefully. Okay. For this one, okay, kalau you extend on the left side, you akan dapat S kuasa 3 CS. Tambah 9S kuasa 2 CS. Tambah 26 S CS. Tambah 24 CS. Okay, so saya extendkan on the left side. Okay, if we take the inverse Laplace transform, okay, yang ni you tak perlu pun refer inverse Laplace transform table, tak perlu. Okay, you tak sempat pun nak refer. Okay, so this is a shortcut saya ajar you. Okay, any S cube, okay, dia akan jadi C triple dot bila kita buat inverse Laplace transform. Ni, you dapat di this part. Okay, any S cube. Dia ikut the power of the polynomial function S, the power of S. Okay, you boleh dropkan S dalam bracket ni, you boleh dropkan. Tak payah tulis pun tak apa. Okay, next one. Okay, ni sebab koefisien 1, you tak payah tulis 1. Tak perlu pun. Okay, koefisien dia 1. Okay, next one. Tulis dulu koefisien. Because of S squared, C akan jadi double dot. S kuasa 2, so ada double dot atas C. So depends. Kalau ni dia pakai Y, so you gunalah Y dekat sini. Kalau dia pakai C, you pakailah C. Okay, depends on the variable given in the transfer function. Okay, so you drop bracket S. Okay, tambah, letak dulu, you just put the coefficient first. So S with the power of 1, C single dot. Plus, so the last one dia jadi apa? The last one dia jadi apa?
Jadi C.
24 C sahaja. Tak ada dot sebab dia tak ada S function. Dia tak ada darab dengan S kuasa 1, 2, 3. So dia jadi C sahaja. So 9C double dot 26C dot 24C equal to RS. RS pun sama. Dia tak ada dot sebab dia tak darab dengan 24S. Kalau dia darab dengan 24S, R, so R akan ada single dot. Clear? That is the inverse Laplace transform. Simple je. You do not need to refer to inverse Laplace transform table. Okay. So ni step number 2. Dan until step number 2 ada soalan? Okay. Next. Step number 3. Select a set of state variable. Okay, called phase variable. Jadi kalau baca the whole sentence nanti you tak faham, kita buat terus. Okay, based on equation in step number 2. Okay, based on this equation, so kita refer kepada equation step number 2. Okay, if you notice, if you still remember, our state space equation, dia ialah macam ni x dot equal to ax plus bu. In this case, r lah dia punya input. Okay, so y equal to cx plus du. Dalam ni dia tak ada du, dia tak ada. Sebab tu dia kosong, dia tulis cx saja. Okay, meaning that we need to represent our signal daripada tadi S kuasa 3, S kuasa 2, S kuasa 1. After we convert, after we take the inverse Laplace transform, we need to determine a set of state variable. State variable kita ialah X. Ni, this is our state variable. This is the X dot is a derivative of the state variable. Okay, so we need to determine our state variable. Kita ada X dalam ni. So how to determine the set of state variable in step number 3? So kita refer kepada equation step number 2 after we take the inverse Laplace transform. So start daripada 24C. The function without S tadi tu. Ni tak ada S tadi kan? Ni tak darab dengan S kan? Okay, start daripada situ dulu. Okay, so this one. Okay, this one will be 24 x1. This is how we determine our state variable. Okay, kita akan start daripada function yang tanpa S. That one will be x1, 24 x1. Next, dia akan jadi x2. Next, dia akan jadi x3. Okay, boleh follow? And the most left, dia akan jadi x3 dot. Dia tak boleh jadi x4 The most left, which is the highest polynomial equation, in this case s with the power of 3 ataupun s cube, dia mesti dia jadi x dot. So kalau ni the last one ialah x3, dan sebelah kiri sekali dia akan jadi x3 dot. Kalau x2 lah yang paling terakhir you punya state variable, di sebelah kiri sekali dia akan jadi x2 dot. Okay, kita ada 3 state variable x1, x2, x3. So the last one to represent our highest polynomial order, dalam kes ni S kuasa 3, dia akan jadi x3 dot. Dia kena ada dot untuk this one, untuk the highest polynomial order. Okay, you tak boleh ada x4. Dia kena ada x dot, so take the the last state variable, you differentiate dia akan jadi x3 dot. So that's our state variable. Okay, based on equation in step number 2. Okay, so ini sama dengan 24R. Input ni tak ada apa. You determine the state variable based on the left side of the equation. Yang ada S kuasa berapa tu. Ada soalan setakat ni? So kalau, okay, if your highest polynomial order yang diberi dalam pada denominator ialah S kuasa 2, maksudnya you ada X1, X2 dan X2 dot sahaja. In this case, you ada S kuasa 3, so you ada X1, X2, X3 dan X3 dot. That's how you determine the state variable in this case. Any question? Okay tak?
Okay.
Very good. Yang lain?
Ya, Madam.
Very good. Thank you, Ami. Syamimi, Balkis, Wafi.
Okay, madam.
Very good. Okay. Okay, next. Tak habis lagi sebab kita belum dapat yang dalam yellow box tu, kita belum dapat lagi. Okay, now. If you compare this equation ni, yang kita dah determine after we take the inverse Laplace transform dengan kita dah determine state variable. If we compare between these two equation, kita observe C sama dengan X1. This one. C dot sama dengan X2. C double dot sama dengan X3. C triple dot sama dengan X3 dot. Here. Okay. Tak habis lagi dalam yellow box. Belum complete. Ada soalan? Do I need to repeat? Faris, okay? Arif?
Okay, madam.
Okay. Okay, next. Saya conteng di sebelah sini. So, kita tulis balik kita punya equation tadi. Yang kita compare dua equation ni. Okay. So, saya tulis balik. Okay, kita tulis balik X1 sama dengan C. X2 sama dengan C dot. X3 sama dengan C double dot. X3 dot sama dengan C triple dot. Okay. Next. Kita nak dapatkan yang complete sama dengan macam yellow box kan? Okay. So for this one, based on the first equation, X1 sama dengan C dot. Okay. If you refer to your transfer function, C is actually equal to Y. C ialah you punya output kan? In this case, kenapa dia sama dengan Y? Sebab you akan guna equation kedua dalam state space. Dia pakai Y sebagai output. Dan C tu ialah untuk matrix dia. So you kena tukar. Apa-apa alfabet yang diberi dalam soalan, dalam transfer function, dia pakailah alfabet apa-apa pun, you kena tukarkan dia kepada Y sebab you akan guna dalam second equation of the state space. Okay. So, first equation X1 sama dengan C, yang mana C is equal to Y. So, you dah dapat complete set of first equation yang ni dalam yellow box. Okay, next one. Okay, next one. If we differentiate these two, differentiate maksudnya you letak dot kan dekat atas. Okay, you apply the differentiation x1 dot. If you differentiate x1, C pun dia akan differentiate. So you kena letak simbol dot dekat kedua-duanya. Sebab dia sama. Kalau you differentiate x1, C pun you kena differentiate. Okay. At the same time, C dot is equal to this one. Therefore, this equation is equal to x1 dot. So x2 equal to C dot equal to x1 dot. That will be our second equation in this yellow box. Clear? Boleh follow? Okay tak ni? Ada soalan? Amirul, okay?
Okay, good, madam.
Okay, okay kot. Dia ada kod kat belakang tu. Okay, next. Okay, if we take these two, kita differentiate. So, C double dot. Sorry. Sekejap pen tu. Kita ambil ni. Tersalah ambil. Okay, so if we differentiate these two, dia akan dapat x2 dot sama dengan C double dot. C double dot sama dengan x3 x3. So the third equation boleh juga sama dengan x2 dot. Ya. Okay tak? Okay, next. Kita ambil yang ni pula. Okay, then we differentiate. So dia jadi x3 dot sama dengan C triple dot. So this one ialah ini. So we have complete our set of state variable as in yellow box. Okay, so ni kita dah dapat. This one pun kita dah dapat. So that is the answer for step number 3. Determine a set of state variable. You dah determine the relationship between the state variable x1, x2, x3, the derivative of the state variable x1 dot, x2 dot, x3 dot, and also the output y and c. Y dalam state space equation, C daripada transfer function diberi dalam soalan. Ada soalan untuk step number 3? Tak ada soalan? Okey tak? Ada mana-mana part yang saya perlu repeat?
Setakat ni okey, madam.
Okay, very good. Okay. Next. Okay. From, okay. Okay, kita belum construct lagi kita punya state space equation. Okay, kita baru step number 1, 2, and 3. Okay. So, based on our, this one, yeah. Based on our step 2, once we determine our state variable x1, x2, and x3, we can rearrange this one into this one. So, kita nak cari x.3 sama dengan apa? So line tu you bawa ke sebelah kanan. Combine dengan 24R. Okay. Settle Step 1, 2 and 3. Tak ada soalan kan? Okay. I'll proceed with the construction of state space equation. Okay, now. Okay, this x dot ni, okay, the derivative of the state variable, you boleh tulis sama ada x dot je ataupun sebab you dah tahu you ada x1, x2, x3, you dah tahu you ada x1 dot, x2 dot, x3 dot, you boleh tulis dalam bentuk macam ni. Okay, tall matrix, okay, x1 dot, x3 dot, x1 dot, x2 dot, x3 dot. Okay, this one pun you dah tahu you ada x1, x2, x3, you boleh tulis dalam bentuk macam ni. Otherwise, you boleh juga tulis dalam bentuk macam ni. Tak ada masalah. You nak tulis x dot sahaja equal to a multiply with x ataupun you nak tulis dalam bentuk macam ni pun boleh. Okay. Okay, now let's construct our matrix A first. Selalunya memang saya akan advise student construct matrix A dulu, followed by matrix B, then the last one will be second equation. Selalunya matrix D ni kita jarang ada. Okay, kita ada matrix A, B, C. Okay, now let's construct our matrix A. Okay, pay attention. Okay. Based on this equation, okay, based on this equation, ni equation ni. This equation to this equation, x3 dot, our final equation after we rearrange in step number 3. Okay, we want to transfer into matrix A first, followed by matrix B and C. Okay, now check column, macam mana nak fill up matrix A. Okay, this is for x1. This is for column 1 is for x1, column 2 for x2, column 3 for x3. Clear? Okay, row number 1 is for x1 dot, the derivative of x1. X2 dot, the derivative of x2. Okay, row number 2 is for x2 dot and row number 3 is for x3 dot. Okay, so kena tahu position row untuk siapa, column untuk siapa. Okay, now we have complete equation for x3 dot. Then we can fill up, okay, we can fill up the third row first. Okay, we have complete equation from step number 3 for x3 dot. Then we can complete the the third row first. Okay, since the first column is for x1, so this is untuk x1. Okay, so take the coefficient with the polarity, put it here. Okay, then refer to our x2. Take the polarity and the coefficient, put it in the second column of the third row. Second column for x2, third row for x3 dot equation. Ni x3 dot sebab tu kita fill up the third row. And then for x3, we take the polarity with the coefficient, we put it here. So this is for column number 3 for x3, row number 3 for x3 dot. Ada soalan setakat ni? Kita tak habis lagi tau. Okay. And then for matrix B, untuk third row juga. Okay. Kita ambil this one. Masuk dekat sini. 24. Sebab dia darab dengan R. So kalau dia pakai U kat sini you kena pakai U. Sekarang dia pakai R. So letak you punya input sebagai R. Dan the third row of matrix A and B. Matrix B you nak construct later pun boleh. You nak construct sekali dengan A dan B for the third row pun boleh. Tak ada masalah. Ada soalan? Tak ada soalan? Okay, kita break 10 minit. Kita break 5 minit hari ni saya nak habiskan awal. Thank you. Kita sambung 3.10.
Okay, madam.
Okay, boleh continue.
Boleh, madam.
Boleh.
Okay, next. Let's fill up first row. Okay, kita nak fill up first row. X1 dot. Okay, for this one, ya, saya padam balik yang ni, yang dalam yellow box. To fill up the other part, okay, we have to refer to the yellow box, set of state variable. Okay, so for x1 dot, you cari equation yang ada x1 dot. This one. Okay, so this one, you need to fill up for the first row. So in this case, equation of x1 dot is equal to x2 only. So x2 kat mana? Dekat sini. So sebab tu dia letak 1 dekat kolom kedua, row pertama. Okay, so x1 dot is not related to x1 sebab tu dia kosong. X1 dot is not related to x3 sebab tu dia kosong. And then x1 dot is not related to the input R sebab tu untuk matrix B, first row kosong. Soalan? Okay, next. Okay, next, let's fill up for the second row. Okay, so you find the equation that has x2 dot, this one. So you fill up for the second row. So in this case, x2 dot is equal to x3. That's why x3 kolom ketiga sama dengan 1. Okay, so x2 dot is not related to x1. That's why we put 0 here. X2 dot is not related to x2. That's why you put here. X2 dot is not related to input R. That's why you put 0 here. Then we have completed our first equation, matrix A and matrix B. Ada soalan? Tak ada? Okay.
Okay.
Good. Okay, next. Let's fill up the second equation for y. Okay, so cari equation yang ada y. So this one. Okay, so kita y equal to x1. Nah, C ni tak payahlah. Okay. So this one. Sorry, salah pula. Okay, this one, y equal to x1. That's why we put here. Ni pun sama juga. First column x1, second column x2, third column x3. So y equal to x1, we put it 1 here. Y is not related to x2, we put 0. Y is not related to x3, we put 0. Okay, dan dia tak ada related dengan R, so kita tak perlu letak DU kat sini. Yang ni kita letak B sebab untuk X3 dot dia ada relationship with R. X3 dot dia ada relationship dengan 24R sebab itu kita ada satu dekat bawah, dekat row ketiga. Okay, row pertama kosong, row kedua kosong. Untuk D, tak ada relationship langsung dengan Y. Okay, input tak ada relationship langsung dengan Y sebab tu kita tak perlu letak matrix D. That's it. We have completed our state space equation for equation 1 and 2. Ada soalan? Before we construct the signal flow graph? Okay. This format of state space equation, dia punya format kita letak X3 dot dekat third row, yang ni nama dia. Dia ada beberapa format Okay, this one nama dia, sekejap saya edit. Okay, this is what we call phase variable form. Okay, so this is phase variable form. There are other format of the construction of matrix. Contoh controllable variable form, observable form, and lagi satu diagonal form. Okay. Controllable canonical form, observable canonical form, diagonal canonical form. Itu nama dia. Okay, so this one ialah phase variable form. So sometimes soalan akan mention what kind of form of the matrix yang dia nak minta. So biasanya dia nak minta phase variable form. So kalau dia nak minta lain, dia akan sebut observable canonical form, controllable canonical form, or diagonal canonical form. Okay, kalau dia tak sebut, you boleh construct dalam bentuk macam ni, phase variable form. Ada juga satu soalan daripada past year exam. Dia nak minta you explain any two of form. Contoh, bagi dua contoh you pilih phase variable form, then you need to describe. Okay. What is a phase variable form? Okay, phase variable form ni ialah yang mana? Ni kita panggil, kita fill up ni tadi dekat bottom matrix A. Yang row bawah sekali, bottom of matrix A. Okay, kita fill up apa? This one is actually equal, kita dapatkan dia daripada sini. The denominator of the transfer function. Okay, nampak tak? 9, 26, 24. So you ada 9 dekat kolom ketiga, you ada 26 dekat kolom kedua, you ada 24 dekat kolom pertama. Tapi susunan dia berbeza. Kat sini nombor 9 yang pertama, 26 kedua, 24 ketiga. Bila you transfer kepada bottom row of matrix A, okay, bottom row of matrix A, you ubah susunan dia. 24 yang pertama, 26 yang kedua, 9 yang ketiga. Yang ni kita panggil reverse order. Okay, so selain kita tukar susunan dia dalam bentuk reverse order, kita tukar polarity dia kepada negative value. Kat dalam ni semua positive 9, positive 26, positive 24. So bila you masukkan ke dalam bottom row of matrix A, you tukar order dia kepada reverse order, you tukar polarity dia kepada negative. Okay, that's describe the phase variable form. Nanti saya paste dekat sebelah sini dia punya description kalau you nak study. Okay. Ada soalan setakat ni phase variable form? Tak ada? Okay, next. Okay. how to construct the signal flow graph. Saya akan habiskan sampai example 7A signal flow graph. So before that, saya nak jump kepada next slide. Okay, on the signal flow graph. So previously, I assume that you have learned signal flow graph from the previous basic control. Okay, in a block diagram, if we have signal like this, okay, in signal flow graph, we need to represent it by node. You kena represent dengan node. So each input, you kena ada satu node. Output satu node. And then katalah you ada X1, X2, X3. So setiap variable tu dia represented by one node in signal flow graph. Okay. Node ni you boleh buat dia kosong macam ni ataupun you nak buat you nak fill in dalam dia ni pun boleh. Tak ada masalah. Okay. And then if you have block diagram that representing the system, contoh you ada transfer function dalam box untuk block diagram, kita akan letak dia macam ni je kat luar, and then dia ada arrow. Dia ada line, ada arrow. Arrow ni mesti dekat tengah-tengah tau. Kadang student dia suka buat arrow kat hujung. Arrow kat hujung tu untuk block diagram. Okay, yang ni arrow dekat hujung untuk block diagram. For signal flow graph, you must put the arrow symbol in the middle of the line between the nodes. Ni nodes ni kan. Between the nodes, dia bukan dekat hujung. Okay. Any question? Clear? Okay. This is if we need to construct, if we have parallel connection. Okay, this one cascade This one cascade, the sebelah-sebelah, G1, G2, G3. If we have parallel connection, G1, G2, G3 as in this figure for the block diagram. So this is the representation in signal flow graph. Okay. And this one for feedback. Okay. For forward path in signal flow graph, the arrow from left to right. For feedback path from right to left. Okay. One more thing. For the signal flow graph, for the block diagram, if you have feedback connection, the polarity is here for the feedback. Tapi untuk block diagram, you kena sekalikan dengan dia punya gate ataupun sistem. Okay, you tak boleh letak dekat hujung ni, tak. Okay, that's not signal flow graph. Okay, you kena sekalikan dengan negative, the gain, which is the negative feedback. Okay, yang ni tak boleh masuk lagi. So back to our example 7A. How to construct the signal flow graph. First, we need to determine how many nodes, ada berapa nodes. So as I mentioned previously, satu input, satu node. Okay, check kita punya, sorry, this one. Okay, check. Saya padam yang ni sebab saya nak explain pasal signal flow graph. So check our signal. How many signal, how many parameters from the state space equation. So first, we have input R1. Okay, we have output Y2. Okay, we have 3 state variable, 3, 4, 5. We have another 3 derivative state variable, 6, 7, 8, meaning that we need 8 nodes in signal flow graph. So kita kena ada 8 nodes to represent each signal, each variable, input, output, 3 state variable and 3 derivative state variable. Okay, next. Okay, yang ni yang dah siap. So saya akan, okay, for the first example, I will sketch the signal flow graph from the beginning. The next example saya tak sketch dah. Okay, so you have 8 nodes tadi kan? Okay, so 1, 2, 3, 4, 5, 6, 7, 8. And then draw the straight line to represent this is the forward path. Forward path. So arrow in the middle. So on the most left is your input R, on the most right is your output Y. You nak pakai R kecil pun boleh, tak ada masalah. Okay. Next, you need to locate your state variable. Okay, you need to locate your state variable. So start with the node, the second most right, sebelah Y ni. Okay, so this one will be your X1. You akan start daripada sebelah node yang di sebelah output. That one will be your X1. Sebelah kiri dia ialah X1 dot. Ini memang susunan dia. Sebelah kiri lagi X2. This one X2 dot. Next X3 and this is X3 dot. Ada soalan? Okay, next. Okay. Okay, as I mentioned previously, yang awal-awal tadi tu, integration dia sama dengan 1 over S. Okay, dalam ni, okay, from X3, ni, this part. From X3 dot to X3, you need to apply integration. Okay, daripada X3 dot kepada X3, you kena apply integration. So, in the middle, antara X3 dot dengan X3, you boleh letak this one 1 over S. Because this is integration function. Okay. Sama juga in between this one. Jadi integration. So this one pun 1 over S between X2 dot and X2. And between X1 dot and X1, 1 over S. Okay. Sebab the integration. Boleh follow? Done? Okay. So let's fill up for, you boleh refer this one. Okay. Yeah. Okay. You nak refer kepada matrix state space equation boleh. You nak refer kepada equation dalam step 3 pun boleh. Okay, tak ada masalah. Okay. So let's say saya nak refer kepada equation ni dulu. Okay, X3 dot. Okay, X3 dot is equal to that negative 9X3, negative 26X2, negative 24X1 and plus 24R. So kat mana X3 dot? This one X3 dot. Okay, so sekarang you dah start kena lukis all the lines connecting for X3. For X3 dot. Okay, for that one, okay, kita ada negative 9X3. Okay, we have negative 9X3. So connect between X3 dot and X3 for negative feedback. Okay, the coefficient is negative 9. This one. Next, we have negative 26X2. Okay, we have to connect between X3 dot and X2. Okay, you buat cantik sikit. Tak sangat Okay. So this one, the coefficient is negative 26. X2. The next one, we have negative 24X1. Okay, so we connect between X3 dot and X1. So negative 24. Okay, and the last one we have 24R. Okay, so R and X3 dot has been connected. So the coefficient is positive 24. Okay. Then we check the equation in the yellow box. Okay, this one. X1 equal to Y. X1 equal to Y. So dekat sini, X1 and Y has been connected. X1 equal to Y. Then you boleh letak coefficient dia 1. Okay, next, apa lagi? This one. X2 equal to X1 dot. X2 equal to X1 dot. Ni tadi X1 equal to Y. Okay, so coefficient dia 1. Next. X3 equal to X3 dot. X3 equal to X2 dot. This one. X3 equal to X2 dot. Coefficient dia 1. Then we have completed our signal flow graph for this example 7A. Ada soalan?
Kalau -9, -26, -24 tu positif, dia punya arrow dia ke sebelah kanan.
There's still feedback tapi coefficient positif.
Okay.
Okay, because X3 dot is actually representing your denominator of the transfer function. Ni, this one. Okay. Okay, tak ada soalan? Very good, Balkis. Sure, tak ada soalan? Okay, yang ni saya explain sikit 7B. Tapi kita tak buat hari ni ya. Saya briefly explain. What's the difference between, sekejap sebelum tu saya nak copy description of phase variable form daripada slide semalam. This one. Yeah, this is the description of the phase variable form. Okay, bottom row of, sekejap eh. Okay, so phase variable form is the bottom row of matrix A, which has the same coefficient as the denominator of the transfer function but negative value and in reverse order. Okay. So denominator of the transfer function tadi ialah X3 dot dalam state space equation. So in reverse order sebab tu dia ialah feedback. Okay. Okay tak Balkis? Okay, untuk example 7B, saya briefly explain je. Kita tak buat lagi hari ni, kita akan continue hari Selasa. So for example 7B is the second case where numerator and denominator is a polynomial function. Okay, dia berbeza dengan 7A, you ada constant sahaja pada numerator. For this one, you need to rearrange your transfer function. You kena divide you punya transfer function. Okay, in terms of this one. Sekejap. Okay, you have to divide your transfer function in terms of this one. You kena bahagi dua. Okay, first part. Okay, so this is the original transfer function. C over R. C is your output. R is your input. Okay, in this case, you divide your transfer function into two parts. Okay, the first part, you just pick X1. Okay, biasanya kita pakai X1. Okay, so the first part X1 over R. The second part kita nak solve untuk output pula C over X1. So when we cancel out X1, we still get C over R. So we need to do it part by part. Where X1 over R, you concentrate on the denominator of the transfer function. On the second part, C over X1, you concentrate on the numerator of the transfer function. This one, first part, X1 over R, untuk denominator. Second part, C over X1, is you concentrate on the numerator. So you need to do step 1, 2, 3, 2 times. For the first part and for the second part. Sama juga, you kena buat step 1, 2, 3. Untuk first part, X1 over R. And then you kena buat lagi sekali, step 1, 2, 3 for the second part, C over X1. Ada soalan? Okay, for the first part, you buat X1 over R, you akan dapat equation untuk X3 dot. For the second part, you buat step 1, 2, 3, you akan ada equation untuk C, which is equal to Y. Dia sedikit berbeza daripada example. Okay, that's it for today. So kita akan continue example 7. Which part tak faham, boleh tanya saya. Boleh message saya ataupun nak tunggu hari hari Khamis kita start kelas tu terus tanya pun boleh. Kalau tak ada soalan, saya nak habiskan kelas. Last call, any question?
Madam.
Yep.
For last class with Sir, the video I can't download the video.
You
Madam.
boleh access tak video tu?
Dia boleh access, dia boleh tengok, tapi nak download tak dapat.
Okay, nanti saya upload the video tu.
Okay,
Instead of
thank you,
giving the
madam.
link, saya upload video. Okay, thank you,
Okay.
Kelvin.
Madam.
Okay, test 2 will be on Friday 1st July. Ada masalah apa-apa? You ada test lain pada hari tersebut? Ada clash ke?
Dia waktu lain.
Waktu
Tapi
lain?
hari sama.
Hari yang sama. So, will you be okay with that one?
Kena okey juga kot.
Okay juga. Sebab mula-mula saya nak tukar minggu ni kan. Tapi ada yang pergi kompo. So, saya maintain week 12. So, study awal lah. Okay? Okay tak? Okay, I think that's it for today. Thank you very much. Assalamualaikum.